I'd like to call the meeting to order and welcome everybody back after the New Year's. Hopefully you've got over the alcohol or whatever you may have consumed at the time. But can I get somebody to a motion to approve the meeting agenda?
Second.
And vote? Aye. Looks like we have one action item. Approval of a design task order for trap rock standby generator design. Let's hear it. Unless I'm skipping something.
And I am a project manager for the water business group, the water operations business group, and I'm also the plant engineer for the Trap Rock water treatment facility. I am here to seek approval for a task order, and the name of the task order is the Trap Rock water treatment facility standby generator design and bid phase services. We're trying to add a second generator to the water treatment facility. Let's see. So before we get into the scope of work, I wanted to talk a little bit about the task order drivers, and that is to increase the redundancy and resiliency of this facility. So the idea here is to install a second generator as a backup to our current generator that we have, and to increase the total auxiliary power capacity of the facility during an emergency. That way we can actually run both generators at a time and get additional capacity to this facility. In terms of the project scope of work, it includes various disciplines. First of all, it includes the equipment procurement. It is a large piece of equipment, a diesel engine power generator, which has a long lead item. And so the idea is to go ahead and try to procure that early, so that way we can save money in both inflation, contractor markup, and other things. So we would have to put a package together and negotiate with the manufacturers early in the process. We have project management, which includes the quality control, but also there's going to be a good field visit in order to have the engineers come in and ensure that everything got installed as shown in the record drawings. So it's all a process of verifying the record drawings and seeing where all the new equipment is going to connect. The electrical design, it not only includes the engineering component of it, but there's a lot of coordination with Novik and the generator manufacturer. Novik is the power provider for the facility. And this generator actually has to be coordinated so that there's a mimic panel that actually helps us transition from auxiliary power to the primary source of power in a safe manner with adequate safety and programming. So the programming component of all of this is pretty tricky, and it requires a lot of coordination. The fuel system, we currently have a fuel tank, and we're going to reuse that, but we're tying into it, so therefore we have to coordinate with the equipment, with the manufacturer of the fuel dispensing system, and we're installing a field, a day tank, and so therefore we have to make sure that all that is talking to one another. HVAC components, there's a large louver. There's two large louvers, and you can see them in this picture in the back. There's a large louver that needs to be installed. There's an existing equipment pad where the new generator is going to go, and there's a plenum and a transition duct that needs to be installed as well. So there's several HVAC components that not only need to be sized, coordinated, but there's programming associated with that, which is a third-party program, which is Johnson Controls. So some tight coordination with that is also necessary. Lastly, there's permitting and bid phase services. Permitting, there's a trades permit for the building department, and there's a air pollution permitting by the EPA that needs to be coordinated in order for this installation to be acceptable and complete. Schedule-wise, the idea here is to get approval for this task order. In the first quarter of this year, the design and permitting phase will take most of the year, 2023. So hopefully we're done by the end of the year with a bid set of documents and go out to bid early next year. Construction will start in the Q3, Q2 of 2024, and hopefully be done by the end of the year, but possibly dip into Q1. It all depends on the long lead items like the generator and whether there's any supply chain issues. The fee breakdown is the following. It's a total of $171,641. The 2023-2032 capital improvement plans have this project itemized. It's PWS 00017. And there's a total budget of $2.1 million for the construction and design of this project. And with that, I'll take any questions. Yeah.
The 2.1 million?
Yes.
Excuse me. The 2.1 million is the overall project, or is that just, you said design, so I want to be
It's
clear.
overall.
That's the overall project.
Overall. So
And
I will probably be back here towards the end of the year, early next year, to seek approval for the construction phase.
yeah, and the procurement of the equipment. How did we determine that 2,000 kilowatts is enough for the plant? And, we have a second one, so this will be number 2.
Yeah, so it's pretty much it's the same size of the one we currently have. And so the idea is to have redundancy. So therefore, we're choosing to go with the same engine generator that we currently have for redundancy purposes.
It does seem interesting that we're right next to the Panda plant, which is one of the most efficient power generating plants in the state and in this region. But that's not the way you get power. It's just can't we just run a line? No, you can't do that. I understand, but it seems crazy. And this is a diesel.
Yeah, it's diesel.
And we have enough storage for how long for fuel for the 2 generators?
Yeah, so we have a 12,000 gallon diesel tank, and that should last us for several days. And so the idea, we have a contract with a supplier, so we could get it in within a day to the facility. So there is space to add more fuel capacity. So if at one point we want to add a second fuel tank, we could.
Mm-hmm.
But currently we haven't really been using it, and we were able to last more than 24 hours with running on generator power, which is adequate in order to get resupplied if we needed to.
Yeah, it's part of our resilience to have the 2. We understand that.
Yeah,
It makes a lot of sense. But I ask these questions because, for the record, as well as because it's important that we have this kind of resiliency.
Yeah.
Yeah, the question is, excuse me, Gerardo, I was under the impression that we were increasing the redundancy capacity, but it sounds like we're providing it. So right now, is there no redundancy for the existing?
No, we do have redundancy. So currently we have 2. So the whole idea is to have not one single item that would fail and shut us down, right? Mm-hmm. So we have redundancy in every aspect.
Okay.
And we currently have the primary source of power, which is Novik, which is a 15 kVA, 12.5 kVA kV line that is coming into the facility. And in addition to that, we have the generator power. We have one generator that has capacity to run 50% of the facility. And so the idea here is to add a second generator. So in theory, we could actually run the full capacity of the facility. Or if that one generator were to fail, we have redundancy to that one generator. So it actually gives us several tiers of redundancy.
Okay, great. So the second generator you're proposing is adding, so we'll have full capacity too.
Correct.
Right. Okay, thank you.
So we have additional capacity and redundancy to the same generators.
How often do we have a power failure?
So power failure, we have a lot of blips right? Like very instantaneous power outages. But in general, we're very resilient in terms of the distribution system of energy coming into trap.
Mhm.
And some of the studies show that the biggest risk are these ice rain events or ice storms.
Ice storms, yeah.
And, you know, in the past, there's been outages of hours worth of outages, right? Anything more than that becomes a little bit more, you know, unusual to have. And so therefore, again, like in terms of like how long do we need to run with auxiliary power, a lot of times it's less than a day in terms of an outage. But in general, we don't really experience a lot of long-term outages. If we have one, it's going to be like a few minutes. I think that so far we haven't had more than that.
And all of our sensitive electronics is on no break power and isolated power, as
Yeah,
I recall.
Yeah. So we have a lot of UPS power as well.
Mhm.
And so therefore, for that instantaneous period where we're transitioning to the generator, most of our sensitive electronics and PLCs are all backed up by UPS, which is our batteries that are inside of the cabinets of those critical facilities.
And when you have the failover to the generators, how much of that, you can speak on automated versus manual as far as the processes to fail over to the generators?
It's all automated.
Okay, so.
Yeah, it's all programmed into this mimic panel that is also provided by the generator manufacturer. And so that needs to be tested. So, you know, a lot of the scope of work is coordinating that very closely so that it all talks to one another in terms of programming language and also testing it and making the contract or the supplier responsible for it to all talk to one another and work. Because we not only want to fail over automatically to the generator, but whenever power comes back on, we want to transition to the main source of power in a safe manner so that, you know, we don't have two sources of energy coming in at the same time. So there's a lot of safety precautions for that.
I just had a
Go
quick
ahead.
question.
Yeah.
So I know quite a bit about generators because my husband is an electrical engineer. So I spent 15 years in the house just talking about generators.
Mhm.
So one question I did had on that, I didn't want to give you that background, but I just wanted to tell you that,
Yeah.
you know,
Yeah.
because I want to ask you a very pertinent question. And that is with generators generally, and I kind of came in a little late, but I picked
Right.
up. My key question here is with generators, are you guys using parallel systems as well with these generators?
Parallel
Because-
systems.
Yeah,
Yes, so
Yeah.
how we're feeding the power,
Yeah.
right? We need to be able to do a open transition and then a closed transition.
right.
And so whenever we have the switch closed because we're going back to primary power,
Mhm.
in order to make that transition, there's this mimic panel that is actually paralleling the power so that we can instantaneously
Okay.
kind of,
Yeah.
I don't know, I'm not an electrical engineer, so I don't know the exact detail of how this works, but you have to parallel
Yeah.
the power in order to be able to like make
Right.
this fast transition to it.
Right. And the
Yeah.
reason why I asked you that was because to help me and others on the board understand here, not that I
Yeah.
don't, that if you have paralleling systems on the generators, not all generators do, but if you have a paralleling system on the generator, that gives you a stronger backup with
Correct.
generators. Right. So those small blips that happen, because the PLC system and the paralleling system is designed in such a way, they're able to take that grounding blips that you have
Correct.
and provide you a better, deteriorate,
Yeah.
like,
And then you don't have to
Um,
shut down in order to go from one power to the other one.
yeah,
So it makes things easier.
yeah, a better support system. Great.
Correct. And it complicates things quite a bit. So that's,
Because
part of
it's
the
a
scope of
system, right? It's a programming system
Correct.
designed in that.
Yeah.
So, yeah. Thank
is-
you. Yeah, I appreciate that.
I'm not an electrical engineer. From an overly simplistic look at this, you're taking an identical generator and plunking it in place.
Mhm.
The effort should be relatively minimal, which I know it's not. Could you go into more of the peripheral stuff that that you have to do to get this thing
Yeah.
set up? I know, I
Yeah.
mean, from a distance, it looks like, well, you're just putting a generator, I mean, what's the big deal?
Yeah, good question. So, yes, so the original design was developed with space for a second generator. And
Right,
the idea is that whenever the average production of the facility is above a certain threshold, you probably want to have a second generator to be
is a
more
pad for
resilient.
generator too? Is the pad already existing?
Yeah, so the pad is already existing, the space is already existing, but time has already gone by, right? And so like as any piece of equipment, the generator model has changed, the general technology has changed a little bit, sizing. So whenever we go out to get a new generator, there's a couple of variables that are going to change. First of all, like, is it the same manufacturer? If it's the same manufacturer, things would be a little bit easier. If it's a different manufacturer, then talking to one another gets a little bit harder. But the other thing to consider is that if the generator is bigger or smaller size dimensions, is the pad still adequate? So that would need to be checked. And then once you install the generator, you have to verify that all the conduit for all the wiring going back and forth is available as shown originally in the drawings as to going from point A or point B for all the wiring. In addition to that, you have a fuel supply system that needs to be retrofitted, and it's currently just going to one generator. So how do you make all that fuel go to both? That needs to be coordinated. You also have HVAC components, which includes a silencer, an exhaust that needs to penetrate the roof. And so you're going to have to figure out with a roofer how is that going to impact the warranty? Can we penetrate the roof, go through it? Mounting the silencer, which is a piece of equipment on the roof, needs to be coordinated with structural engineers. Installing large louvers as well. Is there any structural components that need to be switched or modified in order to make space for the new? So there's a lot of different variables that could complicate it a lot more than just plug and play, right?
Do you know if it's gonna be the same manufacturer? You don't know that yet?
We don't know yet. So that's going to be part of the scope of work, is to see if we can go with the existing manufacturer. That would be ideal, but it all depends on price, right?
You're gonna do a public bid on it, right?
It depends, like I think that we'll have to evaluate, where the costs are between the manufacturers and see what's most advantageous for Loud and Water.
What are some of the compatibility considerations that you have to factor in terms of having this second generator, in terms of the interoperability when you do failover, and you're trying to do potentially failover from one to the other, as well as failover to have them both up and running at the same time?
Yeah. So that's going to be a discussion during design. So, like at 50% deliverable, we would probably have to talk with the engineer as to how to program it, right? Do we want to fail over to both generators running at the same time, thinking we have 100% redundancy for the whole facility? Or do we want to fail over to one of the generators and then like switch from one to the other, that way giving us 100% redundancy on the one generator capacity that we currently have? And most likely, this is just thinking out loud, but most likely we probably want to install programming for both. So that currently, because our average demands are low, one generator may be adequate for our needs, and that way we have a full redundancy on that. But moving forward, we'll probably want to switch to having two generators kick on so that we have that additional availability of auxiliary power.
Is there a common programming language across vendors, or is there some type of interoperability standard that applies?
Yeah, no,
Okay.
no.
not.
So
That makes a
depending on the
difference then.
vendor, and so that's one of the challenges. And since time has passed, a lot of times, like the technology of the existing panel that we have needs to be verified to see if the new generator can be tied in seamlessly, or if we need to replace like a control board or something like that in order to get it to speak the same language.
Thank you.
So,
it's not just dropping a,
no, I wish.
which I suspected.
Yeah, it gets a little bit more complicated than that. The other component to that is that we're dealing with a lot of entities, right? We have our regulators like the EPA for permitting. We have generator manufacturers. We have Novik, the primary power, and asking them questions and coordinating with them. A lot of times it's not a fast response back. So and they may have some preference on how to do things. And so we have to coordinate with them. And so that adds a little bit of time also to the schedule.
Is this going to require any modifications to Novak's system?
Likely not, because the current design already has a lot of redundancy. So we have, even though we only have one line coming into the facility, as soon as we reach the facility, we have 2 transformers that are converting that 12.5 kV power down to 4160, which is what we take in. And every aspect of that also has redundancy. So in terms of communication with Novik, it's going to be more about the discussion of like whether there's adequate safeties in place to avoid, like feeding power back to them, somehow the energy going back to them as opposed to going into our facility and kind of like the paralleling the power, making sure that they're okay with that. And so that's probably the extent of coordination with Novik.
All right, are there any other questions? Can I get a motion to move that motion to, I would like to move it to a consent.
Make the motion, recommended motion, and propose that it be placed on consent.
Give it a second.
Can we have a vote? Okay, aye. Okay, that was a good explanation.
Thank you.
Thank you very much.
The next item is a capital construction quarterly report.
All right, good morning. I'm Rick Zafel, and I'm going to provide the fourth quarter of 2022 capital construction report. And so my agenda for this morning, I'm going to talk briefly about the first 3 projects there. And then I'm going to go into more detail about the Broad Run expansion to 15 MGD. And then we'll conclude with the quarterly numbers that summarize the current completed and upcoming project, all the numbers for those. So let's start off with the Selma booster pump upgrade. So the purpose of that project was to replace a 20-year-old manually operated booster pump with 2 smaller pumps on VFDs to cover the low flow conditions. And there's some pictures of the arrangement there. And so this was awarded about 8 months ago to CPP Construction. We're still in the early stages of construction, or the paperwork stages, as I refer to it, as we've done bonds and insurance and we're into submittals. But the lead time on the pumps and the VFDs is kind of what drives the schedule for this project. And so the contractor is not going to mobilize until that equipment is ready to come on site. And that won't be till a little bit later this year. So we'll get into the heavy construction and other aspects a little later this year on this particular project. Moving on to the Paragon Park transmission main interconnect project. So the purpose of this project is to kind of improve our resiliency and robustness in the Sterling area to cover us in the event of a major outage. We awarded this contract to CPP Construction at the beginning of the fourth quarter of last year at a $1.7 million contract value. Similar to the last project, we're under construction, but again, we're still in the paperwork phase of this project. This project includes quite a bit of ductile iron pipe and ductile iron valves, which have a pretty lengthy lead time. So we won't get into the major construction and have the contractor really mobilize on this for several more months until those materials and equipment are available to come to the site. Okay, Reservoir Park. So the purpose of this project was to add a park at Beaver Dam Reservoir, and with improved access and also educational opportunities and exhibits for the public. And we awarded this contract about 6 months ago, last year. $17 million value, and the contractor has jumped on it with the construction here, primarily because the initial construction activities are earthwork related. And so the contractor has been able to get started with that and clear the area and do the grubbing and get the site ready for the vertical construction, which will actually start this year. So this one has gotten a good early start. Okay. Yes.
So can we please go back to the other
Yes.
side? So what is the timeline that we're looking at after the earthwork and the grubbing has done, that the actual work starts on that?
Okay, so this one has a 540-day contract time to substantial completion. So the substantial completion due date is approximately the end of this year, beginning of next year. So they have a plus or minus 12 months or so left to substantial completion to complete this work.
And are we on track for the completion date or?
I believe we are, yes.
Okay, okay, thank you.
But next summer. We're hoping. Okay, so the Broad Run expansion to 15 million gallons per day capacity. I'm just going to call out some of this information here. So our change order total through the fourth quarter of last year is 1.8 million, up from 1.6 million during my last presentation. Value of work through the fourth quarter is 54.4 million, translates into 70% spent on the project. And then our final completion date remains at August 2024. And so based on that date, we are 60% elapsed on the contract time. And then just looking at our schedule performance index, this just shows that the contractor is generally earning the amount of money that they plan to earn at this juncture in the project at a 0.98. Okay, now we're going to, yes.
The percent spent is 70%, but the time elapsed is 60. Is there any reason why we're running ahead, why the spending is spending ahead of the time?
So the time elapsed is based on the final completion, and typically in the project, you are 100% spent in terms of the value of work completed at substantial completion. So if we were to change the time elapsed to the substantial completion date, it would be closer to 70%. It's just in that time after from substantial to final completion, you remain at 100% spent. Yeah, that's the punch list time and the closeout time of the project. So, yeah. Okay, so now we're going to get into the expansion project here and take a look at the status of the work. So what I've got up is my colored graphic, which shows this is the pre-construction project status. So we're rolling back the clock to August of 2020, pre-construction. And so this graphic shows everything on this graphic is not started. And this shows the work inside the fence at the plant that is part of the project. In some cases, it's brand new buildings and structures over there at the dump pad as well, and then at the parking structure, and then in all the other cases, it's modifications to the existing buildings. And I will add that there are some structures and aspects of the project outside the periphery of the
It's working.
I'm green again. All right. Okay. So there are a few aspects of the construction outside of the periphery of the plant here, but most of it's within the fence line, as I mentioned. And then also, I don't have shown here the yard piping, but I will add that in a couple slides. So now we're going to jump to the end of the fourth quarter. And so here is our current project status as we stand right now. So we have quite a few areas under construction. We have some areas completed, and then we have one area as of the end of the fourth quarter in commissioning or testing and startup. And then now it's going to get messy. I'm going to add the yard piping on to show these are the major piping corridors and the completed pipe work that's already included in the project. And so just to kind of note here that the project, at this point in the project, we're largely up out of the ground and into the more vertical above ground components of the project. And I'll have some statistics on piping and pipe completed in a couple slides. Okay. All right. Now, just taking a look at some aerial photography of the construction progress here. So we're in the northeast corner of the plant looking southwest. You can see the new equalization tank and vault. Those are completed and getting into commissioning actually this quarter. And then you can see the contractor staging area and just some of the other areas of the project. But we really need to flip things around and look northeast. And this view shows you the heaviest area of physical construction here, the clarifier building expansion and the screen and grit building expansions. And those footprints are firmly established there for the expanded area. And I'll talk again a little bit more in upcoming slides about that. All right. Going to
This
move
has
it.
nothing to do with anything, but how did you take that picture? Did you have?
So we have, yeah, so we have Multivista do a quarterly flyover of the construction. And so they use drones. And so they take lots of nice snapshots of different views of the construction. So it's nice to have that. Okay, so now I'm going to get into a couple of specific areas of construction. Just talk about the status there. So first we'll talk about the influent sanitary pump station. So this was the building that was in yellow a couple slides ago under commissioning. And so at this particular building, we've completed the upgrades. We have our new pumps installed. The picture shows there's one of our larger pumps, and then way down the line at the end there are other two larger pumps. So our three new pumps are installed and they're VFDs, and then also the new either hydraulic or electric valve actuators have been installed there as well. So we're in the process of commissioning those new facilities as we speak here at this point in time. And then moving on to the screen and grit building. So the screen and grit building expansion is right here. And we have completed the structural concrete through the end of the fourth quarter. And so as the work has moved into the first quarter of this year, we're getting into the mechanical work and electrical work in that building. And then the primary clarifiers, the structural work, the structural concrete was completed there toward the middle of last year. And so most recently, the contractor has been doing the architectural work over there. So if you can see the precast panels here, they've been hanging the precast panels on the expanded portion of the primary clarifiers. And then they've also been focusing on the mechanical work as well inside the building, the piping and pumps, et cetera. And then looking ahead to this quarter, they're moving into or adding some of the electrical work as well to that. All right, now we're going to jump over to our thickening and dewatering building. So I've circled that in the picture on your left. And we started construction in that building during the fourth quarter of last year. And they primarily started out with just structural demolition and modifications. So we've got a saw cutting operation there to open up the slab on one of the floors in the building so that we can set a hopper in place. And there's kind of the open slab in the picture on your right. And we're putting a very large hopper in there that spans, more than one floor of the building, requiring us to cut open the slab. And so in this building, the work will transition to mechanical, electrical, instrumentation and control, and HVAC as the work moves through the first quarter and on. This particular building has all the major construction disciplines involved in the work there. All right. So now we come to my summary data here. So I've got all my statistics through the fourth quarter of last year. I've got the total number of submittals and shop drawings reviewed, total number of requests for clarifications that we've answered, that the contractor has submitted. On our concrete numbers there, in the fourth quarter, we poured about or placed about 600 yards of concrete, and that brings our total to about 16,234 yards. So we're approaching the end of concrete. There is really no more structural concrete to be placed. It's more of non-structural or cosmetic concrete for equipment pads and curbs and things like that. And then the yard piping information that I promised earlier. So during the fourth quarter, we installed about 300 feet of yard piping. Again, most of the large diameter yard piping, 24-inch, 30-inch, 36, 48-inch is installed on the project. And so through the end of the project, it's really just kind of smaller diameter yard piping that has yet to be installed, and that will kind of trickle in as we go through the final year plus of the project. All right. It is, yeah. It's a lot of time, a lot of duck to learn. Yeah. Okay. So now we're gonna talk about our summary information here, give you an overall picture of the project here. So we continue to have good communication between the parties. We use the tools in the contract to correspond with the contractor and administer the contract. And so that's going well. The plant continues to meet permit, which is paramount in this particular project, well, in any other project as well. The quality of construction, as with all construction, there are quality concerns, but we do a good job of kind of keeping that list short and keeping things contemporaneous and, having the contractor address quality concerns so we don't get too far behind with those. At present, we have no outstanding or long-standing claims and disputes that we have not been able to resolve with the contractor. So that's positive. Unfortunately, the project is trending late. I shared this the last time around, and I've got the latest number of days that were forecasted late for substantial completion up there. So that's the one dark cloud in all this, but change orders were at 10 executed. We added one to the list since the last presentation. And so I'm going to talk just a little bit more in my next. Yes.
So, we are sort of lagging behind 102 days there. And what's the reason for that? What are the contractors, lagging behind on the construction?
So
The issues we have.
we do have some supply chain delays or claims on the table that they've submitted, and we're working through those. And so that's part of it. I think another part of it is probably just contractor inefficiency, and that's something that we've seen on many projects in the past here. And so, but going back to the first point, the supply chain delays. So we're awaiting something called a time impact analysis from the contractor, and that's basically their analysis of how the supply chain delays might have impacted the schedule. And so once we get that, we'll do our analysis of it and determine exactly how many days the contractor might be entitled to in terms of additional time or a time extension or not. And so, and the rest of my discussion is gonna dive into this topic and talk a little bit more about some of the recourse that we have in the contract to address this and some other things. So.
And you mentioned contractor inefficiencies. What mechanisms that you're having to deal with that? What are some of the, as far as loud water, how are we addressing it? What's being done?
So on my next couple slides, I'll get into that. But I guess when I say contractor inefficiency, I guess it's just sort of a general failure to kind of meet the forecasted schedule. But I'll get into some details of that, and hopefully that'll answer your question here in the next couple slides. Okay. You ready? Okay. So in the risk discussion, schedule delays are the greatest risk to the project. And so I've talked about this in the past, but we do have supply chain delays on the table as part of this project. And they're typically been related to ductile iron pipe, instrumentation, and stainless steel. And some of the things that we have done to try to mitigate these delays and also contractor inefficiency, as I've mentioned, we've worked to expedite submittal reviews to get our responses back to the contractor so they can get to release of equipment sooner, rather than later. Concurrent work areas is a big one. So in our project, because it's a retrofit project, we limited work areas to 6 at any one given time. And we have allowed the contractor up to 10 concurrent work areas at various times, especially over the past year. So we've been generous, where possible, to allow the contractor more work areas than the contract documents allow. Going down the list there, we've also relaxed some contract constraints. And an example of this is just like with certain sequencing aspects in our contract, we have constraints that say, like, you can't do B before you do A. This just is an example. And in some cases, we've relaxed those constraints where we thought we could accommodate the disruption of, going out of sequence while still, of course, meeting permit and, maintaining the needs of the plant. So there's been some of that. Coordination and shutdown requests.
Just a question
Yes.
on that.
Yes.
So I know we didn't do that purposefully, obviously, sitting here on the board. But, and I do understand sometimes you have to do B in order to get to A. But I mean, and we do provide flexibility here in our decision making. But what I don't understand is like, I hope we're not giving too much flexibility here. Sometimes we're like, yeah, we understand, you got to do B to get to A. And, we want to work with you, but we don't want that to be a habitual, consistent pattern. I've seen that before and that's a cause of concern for me.
Correct. So we've been tracking our goodwill on the project with the contractor. And I feel like we give where we can, but we haven't given to the extent that our position or our recourse in the contract is compromised. Okay, so we've maintained, our position in the contract to enforce it and to, to benefit from the aspects of the contract language that are in our favor. So we haven't weakened our position,
Okay.
but we've given just where possible, where we can accommodate.
Right.
Does that make sense?
2 days is it's more than 100 days. Like, I mean, it's more than 30 days. 60, okay, so like on here. So
Yeah.
Thanks.
Okay. So two other aspects of this slide here. The shutdown and coordination requests. So on the project, we have 350 to 400 shutdown and coordination requests to date. And these are requests by the contractor to impact some aspect of the plant for either an inspection or a tie-in or a connection. And so we've worked to expedite those for the contractor to help the contractor out. And then also commissioning as well. So we have worked with the contractor to help expedite the scheduling of commissioning, and particularly with outside vendors. They're typically the vendors have limited dates of availability, and there's vendor interface through the course of commissioning. And so we've worked with the contractor to kind of accommodate vendor availability so we can sort of stay on the planned schedule with some of the commissioning activities.
Rick, Mr. Koblis has a question.
Yes, sir.
Yeah, obviously we've seen this before at Trap Rock, which became a nightmare. It's already 100 days. That's a third of a year. So I just want to make sure that you're keeping track of all the additional time that Loudon Water is providing to get through these extra days, because we'll have to use it against them during the liquidated damages phase. And also because of the extra 100 days, and which will turn into 300 days pretty soon. The architect is going to want, and I mean, the engineer is going to want extra time too. So we just need to keep close track of all that. This is kind of disappointing that we're already this, and I guess, you know, everybody's going to use the supply chain excuse, but anyway, I'm sure that we'll cover that later. But I just please keep track close of all the time that we're spending extra as far as Loudon Water is concerned. Thanks.
Okay. Yes, Mr. Kobos, that Goodwill list that I mentioned, I was just looking at it yesterday. We have 30 to 40 items in there. Some of the items under mitigation strategies are on that list. So we are keeping track of how we've shown, you know, goodwill to the contractor. And that will be a topic of discussion in all of the negotiations that'll be related to the closeout of this. Okay. So
I just have one question. How do you staff this project? Do you have folks on site 100% of the time, or how do you do?
we do, yeah. So there's one other Loudon Water person that's on, and he's generally 175% or so on the project. And then we have a team from Hazen who is providing the construction administration services. And they have,
Okay.
they have several full-time personnel that are on the project. And
I
then,
was just wondering about the Loudon Water, what we have on.
yeah, there's two of us that are serving the project.
But they're also Loudon Water inspectors, right?
Correct. There's
What's that?
there are also Loudon Water inspectors as well. There's a split on the inspectors. So we kind of have half covered by Loudon Water and half by Hazen. Okay. Now just to talk a little bit more about risk, we're going to talk about a couple of aspects of the risk and the project scheduling puzzle that are very important and at times can be competing. And we're going to talk about the things that we've done to kind of balance those out and make sure that we minimize our risk on the project. And so over on the financial side, liquidated damages. So we have been monitoring retainage against liquidated damages, both accrued and also forecasted. And so that's a similar approach to the Trap Rock project that we took. Another item of recourse we have in the contract is a recovery schedule. So we requested a recovery schedule from the contractor. On claims, I've mentioned that we've closed out several complex claims already. I think about 20 or so of them on the project. And then we have several claims on the table for the time that I mentioned. And what we're waiting there is for the contractor's time impact analysis. I mentioned before that the contractor will provide us a time impact analysis, which is their assessment of what they think they're owed in terms of contract time. And then we will analyze that ourselves through our scheduling software and determine and reach agreement on what time they're owed. And this is for supply chain. And so that's kind of the financial picture of things, items that we've done, action we've taken to minimize risk and protect our interests. And then over on the operational side, in terms of plant capacity, we are good on plant capacity through 2025 in terms of the current 10 MGD capacity of the plant as we stand right now. And then also we have worked to maintain a buffer of capacity in the Potomac Interceptor as needed. So we have that latitude there as well. And then just going down to construction impacts, a couple things to note. One is that we have yet to do the membrane work on the project. The membrane facility at Broad Run is really the heart of the plant. It's a very critical and also delicate process. And so in the project, we had an early delivery milestone to have the contractor provide some flow storage and flow pumping facilities that we wanted to have done ahead of the membrane work. And so we're enforcing that. that the contractor does need to provide those flow flexibility facilities before we do the membrane work. So we can't really budge on that. That is paramount. And then just similar lines, there are various constraints in the contract that are related to the membrane work and the sequencing of it. And remember I said earlier, we were able to adjust sequencing in some cases to allow B before A. Well, with the membrane work, we don't have that flexibility, again, because of the critical nature of this process. So there are some aspects of the construction that we can't, there is no wiggle room on. And so again, we're working to balance these aspects out as we go forward, and try to mitigate delays as much as possible.
Question, I saw in the previous slide, there was 10 change orders
Yes.
that were executed.
Yes.
And I'm not, I mean, I'm assuming something of this size, that's not normal. That's probably fairly normal. I mean, this is a large. How did that at all factor into the schedule? Was that already incorporated into the schedule?
So that's changed work that's been added to the contract. So that was not work that was originally scheduled. Now, so far on those 10 changes, there's been no time associated with those. So when the contractor and we, as the project team, settle up those changes, they haven't asked for time on those changes.
Okay.
But the 11th change order, it will undoubtedly have some time in it, and we're working on that particular one right now. So they're going to start to involve some time.
When we say the 11th change order, does that relate to what you just spoke of, or is that something?
The time aspect.
Okay.
So yeah, so we're working on the next change order, and we're hoping to resolve the time associated with the milestone 5, as we call it. That's the flow. The flow storage and delivery facilities.
Gotcha.
That's the early milestone and the prerequisite for the membrane work. We're hoping to resolve that with the next change order. And
Is there like, I don't know much about change orders, so I'm gonna lean on you for this one. For change orders, like, is there a maximum amount of change orders? I mean, there should be a limited amount of change orders, right? You can't have 50 change orders, right? Like, you can't just say, oh, yeah, I mean, I'm trying to
Yeah, I
understand
think,
this
okay.
part.
I think the quantity of change orders is kind of more a function of packaging.
Yeah.
And so in our particular case, we package quite a few things in each change order. So there may be 10, 15 items in a change order, but I know there are laws about the dollar value or in the total dollar value of the change order as a function of the total contract price.
Right.
I don't know what that number is, but I know there is a limit. Somewhere when you get to 50, 100% of the contract price in change orders, there's legal implications with that.
Right. I mean, I would think there's a reason why I asked. I'm glad you said that, because I'm like, sitting on the board, it's like cost attached to everything. So you think in that mindset. So that's the reason why I asked you. But okay, great. Thanks.
You guys are pretty low on change orders, percentages.
We
Lower
do
than
try
others
to, we
do
do try to be low.
But
yeah.
you're saying that there's a legal limit to how many change orders you
I
can
think
have?
the dollar.
The dollar value as a
I deal with change
function,
orders all day. so-
yeah, as a function of the contract price.
So it's legal to have a limit to,
I don't know what I'm thinking about federal, but I know I deal with change orders all day and from a federal perspective, and I deal with a lot of them. So I don't know
Yeah.
if there's any quantity, maybe there's a dollar.
but there's no limit on.
The
on
quantity,
either?
not on the number of change orders that I know of. But the dollar amount, there's probably like you stated.
And I just want
Right.
to remind that the board has approved a financial contingency for this construction project. And those are change orders that we're allowed to work through with the contractor. And once we set that value, it's 2%, right?
It's 5%,
5%.
5% contingency.
We'll come
Right.
back to the board and talk to you about if we need more. This is well below any legal limit that
Yeah.
we might hit for the financial value of change orders that would draw concern. So the board will hear if we get anywhere near that 5% capital construction value on change orders. We'll talk about what that next part might be. You would have to vote to approve that.
Correct. Right. Okay, so the closing point I want to make with this slide is just, we continue to have a good working relationship with the contractor, and we will continue to work with the contractor to resolve the time issues that we have on the table. And then here's my summary information. Here at the top, I've got the projects under construction, and to Kendra's point just a minute ago here, on the Broad Run project, our change orders as a function of the contract value are 2.3%. And if you remember, we have a 5% contingency. So we're not even halfway there on using the board approved contingency. And then we've got the other projects as well that are in construction or on the list at the top. And then in the middle there, we've got the Trap Rock flow meter and sample line project that's going to drop off the list. It's the last time you'll be seeing that. And then up and coming at the bottom, we have the Broad Run reclaimed water pump station project. So that was approved by the board last quarter, and we anticipate the notice to proceed date to be early next month, and that project will get started. And just so you know, on the up and coming projects at the bottom, I'm only listing projects that have been approved by the board and awarded, and they have an anticipated notice to proceed date for the next quarter. So when you see the next iteration of this table, there'll be more projects on the up and coming section on the next quarterly update, because there are definitely some projects in the queue that are we're either opening bids or getting ready to present to the committee and the board on those.
I can't remember. Have you guys ever exceeded the 5%?
I think there have been times in the past that we have, but I think it's the exception rather than the norm. Any further questions?
No, just say thank you. It seems like quite a complex project, a lot of moving parts, a lot of moving resources. So
It is, yes.
Very good presentation.
yeah,
Thanks.
I know when I had construction, if we had 1.9% change orders, I would have sold my firstborn child for that. Are there any questions? Thank you. What's the next item?
Good morning. This is the look at the capital spending report through the end of the year. And I'll just make the note that these aren't quite the final numbers. This time of the year here in January, there are still commonly invoices rolling in for work that was done maybe in December. And so as those get finally processed, you'll see maybe a slight change in the value of where we end up at the end of the year. But for all intents purposes, that change is insignificant. So these are pretty close to what the final numbers were for the capital spending last year. And if there's any questions, I'd be happy to try to answer them.
Quite a difference from the original. Not the mid-year projection, but from the original.
Yeah, and just looking at that and generally trying to understand what the impact was, is that really it's just a lot of projects with kind of the very standard types of delays that occurred in the project, slowing down progress, whether, as Rick just was talking about, some of the projects, whether they're in construction or design, but really no significant other factors affecting last year's spending. No big projects that we had forecasted to do that we've stopped or anything. But so the money that we had projected we would spend this year that we did not really is rolling over into 2023's spending. I said this year, I guess I got myself confused because it's already January. So the money we projected that we would spend in 2022 that we didn't is now rolling over into the project spending for this year. So.
Any questions?
Okay, great. Thank you.
The next thing is the work plan, 2023 work plan.
Mr. Koblis has a question, sir.
Yeah, Marty, I'm just curious why nobody's sitting anywhere near you.
Hey, I showered this morning. What the hell?
Good. Can you guys hear me? Good morning. So I just wanted to, I'm not going to spend a lot of time on this, just wanted to kind of put this up here. This is our anticipated work plan for CIP committee for 2023. Next month looks to be like quite a busy month. I think this year we're probably overall primarily going to be focused more on construction than design. There are a number of bids that are closing, either closed in the last couple of weeks or closing in the next week. So we'll bring those forward in February. I'm not going to go through all of this. I want to point out a few key things. We are this year going to be starting a project with the county on Paonian Springs and addressing their public health needs on the water and wastewater side. So you're likely to see something coming in this spring on that. And then in June, you will see something on the community systems ammonia removal project. This is our first progressive design build project that we're doing. And then in August, some additional work on Broad Run phase 3. And then in September, some contracts, hopefully the award of the construction contract for the quarry, as well as some engineering services for the quarry or CA services for the quarry. So I'll take any questions, but just what I wanted to point out to you.
I have one question. I noticed in just on May, you mentioned Potomac River vibration monitoring system. Is that connected to the issue that we had when they first installed the pump, and that's one of the pumps in that station?
Yes, and Jessica, I don't know if you or Gerardo want to take that.
Yes,
Is that
Yeah.
connected to that issue?
that is correct. As a result of some of the lessons learned from the troubles that we had with vibration, we decided to install a new monitoring system that monitors the below ground vibration. So that way we can protect the pumps and protect those assets.
Have we ever figured out what was wrong with that pump?
We don't have a smoking gun necessarily, but we were able to resolve it by addressing various things. So we changed the line shaft bearing material. We think that probably had the most to do with it, but we're also take a couple of like operational differences in terms of how we run the pumps, and we also replaced the type of we hardened the shafts so that they're harder to erode. So as you recall, these are open line bearings, and so they're being lubricated by the liquid that is being pumped. And so sometimes if the liquid has a lot of like debris and material, it can erode either the bearing or the shaft. And so since we replaced the bearing material and we hardened the shafts, we seem to be having no problems right now. But to protect the assets, we're installing additional vibration sensors on the bottom of the pumps so that we can identify if it's going out of the norm in terms of vibration, and we can act faster to protect the asset and avoid more serious
It's not
repairs.
just for that one pump, this is for the whole.
It's 4 pumps, yeah. So, yeah.
Does anybody else have any questions?
board plan. It's really nice and simple. And
Thank
it's- Yeah, it's, I like it. I like that. I'm actually gonna take that and copy that in my day job.
You're
I
welcome
make
to.
it complicated. Thank you so much. Appreciate that.
Welcome, thank you.
I suspect that the Panonia Springs is going to be a rather complicated project.
Do I have a motion to adjourn?
Motion to adjourn?
Second? Vote? Don't want to adjourn? Okay, thanks, everybody.
Thank you all.